Hi, welcome to the Signal Path. In this episode, we're going to talk about X-ray fluorescence, which is a really interesting measurement technique for analyzing elemental compositions, particularly of metals. This started when I bought a broken X-ray fluorescence machine off of eBay, but unfortunately it was packed so poorly on its way to my house that it had many other damages sustained during the transit, so I had to go through rebuilding it from scratch. So this video is in two parts. The first part is all the repair and all the taking apart and putting back together of the machine, and in the second video, which will come up shortly, I will discuss the exact science behind it, how it works, and then we'll do a whole bunch of experiments on different materials. I'm sorry for splitting this into two, but this has been going on for many months as I've been trying to build things. In the background, there's also two different experiments for two different videos, both of them really fascinating. So if you want to see this, make sure you subscribe to the channel. Let's get started. So here's what the machine looks like when it's all put back together. It's actually quite heavy and it has a lot of depth in it, and this is the window where you load the sample in, and that's one of the reasons why it was damaged. So in the next shot, we're going to go back several months from when I received it and slowly putting it back together. And here's the main unit sitting on the floor of the lab. It did have a cover all around it that was kind of broken, so I've removed it for the purpose of the video and removed the top cover. It's the front door of the unit, which is also was broken completely off. It also protects you from the X-ray, I think, to some extent, and has the interlock switches, and there's a LED lights controller in the front. Now, interestingly enough, this module over here is everything that has the X-ray source and the detector and all the motors and everything in here. And it looks like it is removable. It does have these handles, so somebody has placed this in here. But all of that interface goes into that mess over there, and you can't remove it without disconnecting it from there. Now, the odds of us fixing this is pretty small given how much damage it has received, but I think there's a lot of education in here to learn about how this works and talk about the theory of fluorescence along the way. So let's take a look. So there are two doors in front of the instrument that can be opened. One of them is the glass one. I managed to straighten it out and put it back on the rails. There's a counterweight attached to it via this cable that allows it to kind of smoothly go up and down. And there's a door at the bottom which you can open where you can slide in the sample into the unit itself. Interestingly enough, there's two interlocks, one on each side, both for the top door and the bottom door. So there are 4 switches in total that need to be engaged, I'm guessing, for the X-ray to be enabled. So those interlocks mean that they really care about whether this is properly closed or not, because even if you close it a little bit at an angle, only one of the interlocks will be activated. But there's no other interlock that I can find anywhere else. So if the unit is taken apart, for example, or a top is missing or something on the side is missing, you wouldn't know. I mean, there's only so many interlocks you can put into something like this, but they clearly care about that. It's all cleaned up, and I did the best I could. Now, this is where the X-ray unit was sitting. Now it's time to pay attention to this. And here's that mess of wires that interfaces everything together. Now, most of these lines coming out are just interlock switches and stepper motor controllers to move things around and find out when things have reached their limits. There's a few analog interfaces, particularly this one goes into a box that says do not readjust, a high voltage power supply going in. So I'm pretty sure that this does no interpretation at all for the fluorescence information from the X-ray detector. All that signal appears to be sent to the PC card in an analog format, and I think that then performs computation and figures out what's going on. This box is essentially dumb, just as most of the controllers. But because nothing is labeled, I have to be very careful. Removing everything, all of these wires is essentially required to remove that main X-ray unit, because there's really nothing else in here. All these cables go into that. Okay, I managed to remove the X-ray unit, and I cleaned all of these cables and everything over here. So this board is the main X-ray tube controller and a whole bunch of other interlocks that come into this. There was another board in front of it which I removed completely so I don't have to disconnect the cables from that. That's with the main X-ray unit. This over here does have a high voltage BNC connector, so it could be the focusing voltage generator segment for the X-ray tube itself. There's a transformer here for the main input, and it is only 115 volt because it's directly linearly connected, so there's no switching supply in any of this. And there's nothing unusual. There's a power cable here. This was going into the X-ray high voltage power supply, which was sitting over here, so that's gone right now, so I can clean it up. And here's the fun part, the main X-ray fluorescence head, and I took some air to it and got all the dust out as much as I could. I haven't done any work on it yet, but we should be able to analyze at least some of its subcomponents. I will describe the theory of X-ray fluorescence, hopefully if we can get the whole thing working afterwards, so you can understand how it works on the physical principle, but at least we can see how the hardware looks over here. So this thing here is a stepper motor, and the whole purpose of this is to just move this stage up and down, because you need to focus both the X-ray as well as, of course, the camera over here, so then you can see what it is that you're looking at, because the depth of field is so shallow and you're looking at really fine features with this instrument. And you can see that stepper motor is connected to all of these belts basically, and all that does is that when it turns, it's just going to turn all these screws in unison, and this whole thing is going to move up and down, so nothing unusual there. And this is the camera. That camera connects to a bunch of mirrors and looks at a sample. We'll see the other side. But this is what was supposed to be faulty. Basically, no image was coming out. And without this camera, you don't know where the X-ray is pointed to. So it's going to be very difficult to use this instrument. But if I look at this, there are only 4 wires going to this camera, and 2 of them must be power, the other 2 must be just composite video. So I think this thing just puts out composite video, nothing unusual about it. And then it goes over here, and there's some conversion to basically take it into this coaxial. This connector doesn't look very good, so I wonder if the problem is in here or if the camera itself is dead. Nonetheless, I think we can remove this and turn it on separately and test that without this whole thing, see if we can figure out if the problem is there or maybe just was it this connection issue. The rest of it at the bottom here, this is our main X-ray tube, and on there is a thermochromic little thermometer attached to it that changes color depending on the temperature. It must be just something for diagnostics, but you can't see this from the outside. Anyway, now right underneath that, that thing over there, is in the way of the X-ray output on the other side, and it's a shutter, and I think it's basically an X-ray shutter. I've never seen one of those before, but I wonder why it is there, or perhaps it serves some other purpose that I can't figure out quite yet. These individual optocouplers just set the limit on where this stage can travel, so this basically goes in between these two to tell the stage that it has reached the upper limit, and there is one over there for the lower limit. So nothing crazy over there. Now, if I look at this, it kind of lacks a certain level of finesse in terms of its engineering. It's kind of hacked together all over the place, most likely because it is such a low volume, probably. I don't know how many of these they must have made or sold, but because of that, they didn't spend a lot of time making all nice mechanical, everything fitting together. I mean, everything is kind of zip-tied, all the cables are all over the place. But that's probably more of a volume issue. But if you really wanted to make this super nice, I mean, you could, but it would then either cost a lot or it would never make its money back. And here's looking from a different angle. This is the high voltage input directly into the X-ray tube, and this must be the focusing point. I was mistaken, that other cable does not go here. It actually goes into the detector, as we will see. Let me look at all these cables. I have to clean all of this up. And here's the grounding terminal of an X-ray tube. The X-ray tubes are really important to be grounded, and we see this all over the place every time we look at an X-ray unit. There's some controller board over here which connects to a whole bunch of stuff. Nothing really crazy or unusual. Here's the other side of that servomotor you were looking at, and here's one of the belts that it is connected to. Let's turn it one more time. And another 90-degree turn, and here's the fan blowing onto the X-ray tube. Nothing surprising, but this must have been running for a long time in a fairly humid area because there's some rust on this, and it's just dust everywhere. They must have never turned this machine on. And you can see the other side of that shutter with a control over here which controls the shutter. There's a part number on it. It might be worthwhile to dig it out, see if we can get some more information about it. Now let's look at the fun thing, which is the front. And here's a part of the instrument that faces the sample. And there are so many detectors and sensors, both optically and mechanically, to make sure that this is not colliding with the sample, as well as tell its proximity to whatever it is that you're trying to measure. Even this board over here with all these LEDs on it is on a spring, so that when you press, there's a button on the other side, so you know that you're hitting something. There's switches here, 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 and this one is actually broken, so I think something must have hit it at some point. And there are IR detectors all over the place. There's even 2 over here, and there's a couple in here that are pointing directly into the sample. This could just be for lighting, so the camera can see what it's looking at. So the camera's opening is over here, hard to see at the bottom, but there's a mirror in here, and it reflects off of this, and it looks at the sample. So if you put a sample over here, the camera can see it. At the same time, this thing over here is the opening aperture of the X-ray, and that goes through the mirror too, which is kind of funny. So the point of the X-ray and the camera look at exactly the same place, which is what you want, because you're trying to sample what it is that you're exactly looking at. It's a pretty interesting design. Here's our detector, and I was mistaken. That cable actually goes into this detector in this box, the preamp or whatever it is that's inside of this. And there is a stepper motor up here that opens the window to the detector, and there's an interlock switch on that too. If I turn it, you can see the beryllium window right there. You're never supposed to touch that with your hand, of course. And then if you go over there, this actually closes it. There's a switch that tells you that you've reached the closure. Different openings can have different filters on it. I don't see any filters in this, which is interesting. X-ray filters, I mean. But that is opens, basically allows the detector to start collecting data. There's a laser over here. This laser comes over this, and it points to the sample so you can see where you should be placing it. So there's a lot going on over here. Pretty neat design. You can kind of hack together, but it's certainly not simple, and it's quite complex. So let's now going to clean this up a little bit. I'm going to figure out if we can hopefully try the camera first. So I went ahead and took the camera module out, and ironically the only thing that I have that accepts a video input is this gigantic TV here. But as you can see, the camera indeed works. There's nothing in focus because there's no lens in front of it, but I'm not so sure what could have been wrong with it. Maybe it was just a bad connection, but that seems to work. So let's put it back in there and continue assembling. Well, after about 6,000 zip ties, I put everything back together. I have a rough understanding of what connects to what now. Everything is in there except the high voltage power supply that goes over here, and this is the plug for it. You can see this elongated part isolates the high voltage from this ground contact over here. It goes deep inside of the power supply module, so that needs to be plugged back in there. Everything else is connected. This is the temperature sensor for the X-ray, so that it monitors to make sure that it's not overheating. I lubricated all the movements inside of the head, cleaned the mirrors and the lens of the camera, so hopefully we can see inside of it. I can power it on like this just to make sure that it doesn't burst into flames, but I can do that without the X-ray power supply connected, just in case, and that should be something I can try. And here's the back of the unit after everything's been put together. The interface to the computer is really quite simple. We do have the U and D, these DIN 25-pin DIN connectors that you saw the boards that are on the inside that connect to these. And then we have the video output. That's what was connected to the TV when I was trying to make sure the camera works, and the preamp. And I think the preamp is probably the only signal that comes from the detector. So there must be a digitizer and something in the software to take advantage of this. I'd be curious to take a look at this if we can on the oscilloscope, if we ever get to that point. But the rest is just power, and of course the fan in the back. Now the computer is in a much worse shape. It basically kind of disassembled itself in transit because it wasn't properly packed. Let's see if we can bring that back to life. And here's the computer, and it basically arrived in pieces. That's because most of the connectors in the back of these cars were still attached when this was put into a box, and that forced everything to be ripped out of the motherboard and dangling and bouncing around inside of the case. The front of the computer itself was also completely broken, which is just a plastic shell, but everything else is bent out of shape as a result. There's a few things that concerns me. There was also a monitor, by the way, in the box, and the monitor is completely destroyed. Basically the LCD is broken, but that doesn't matter so much. We can easily replace that. Few important things here. Obviously the hard drive with the software on it is pretty critical. This card, which is interfacing with the X-ray machine, is pretty significant because it's got the preamp input and the controllers. This is some proprietary thing and it doesn't even have any markings on it. We should take a closer look at it and see how it is built. And this is an all-in-one ATI card. I remember having one of these back in the day. This basically has a TV tuner, video capture, and also a video card. And this is how they're capturing the video from the camera and superimposing it inside of the software. These are pretty cheap. I found one for about $20, which I bought because the connector is completely destroyed and out of shape. So I don't think we will be able to bring this one back to life. But I'm mostly worried about this card. At the same time, there's this Sentinel kind of thing. This is a key for the encryption for the software, and this was also bent, and I hope that it is okay because it's potted, but I tried to straighten it a little bit. It does get detected by another computer but without drivers, so hopefully this would work. Without this we cannot run the software. So let me work on this a little bit and see if we can get something from this computer. Well, the situation with the computer was also pretty bad. First, this video card was completely dead, and I think it must have been developing problems even before the shipping. That's probably why the video wasn't working. But when I plug this in, all the memory chips get super hot and there's no picture. So this is definitely dead. So this has to go, and I already found the replacement. Now the hard drive also had problems. If you look carefully, the SATA connector is actually broken, and these pins are just kind of sticking out. With a lot of difficulty, I managed to get enough of this working to clone the hard drive, which was pretty important because the software I couldn't find anywhere anyway. So that's been cloned onto an SSD, and that SSD is now pressed right over there, so it boots pretty fast, so it's going to work just fine as well. And you can see that the new video card is in there, and the controller, the pulse counting, the preamplifier and everything is the controller board itself is also in there. Hopefully that works, but it does boot now, so we should be able to test it with the system. So there have been some updates. Let me bring you up to speed. After I got the software on the instrument working, I managed to get the software to interact with the instrument, which was fantastic. The stepper motors were moving around, the interlock switches were being detected. I could actually initiate a measurement. And I placed a piece of copper inside the unit and I tried to make a measurement. But there was absolutely no signal being detected at all. No pulses were coming out. I took a look at the preamp signal directly. Absolutely nothing. Now there are many reasons why this could happen. For example, we may have no X-ray at all, or the X-ray shutter may be broken. In that case, X-ray will never hit the sample. There will be no fluorescence. There will be nothing to detect. But that's actually pretty easy to verify because I can place a radiometer inside of the chamber, and the radiometer will tell me if an X-ray source is coming out of the tube. And both the shutter and the X-ray source seem to be working. I could detect that presence of X-ray using this without any issues. Now, another reason why we would be getting no pulses would be if the tube is not biased or the tube is broken, the detector tube I'm talking about. Well, to measure the high voltage power supply required for the detector tube was pretty easy. That was this box right over here, which had a cover on it that said do not adjust. And that's because this high voltage power supply has to be very accurately set in order to be able to make the correct measurement of the spectrum. Otherwise, the whole thing will be shifted. So as a result of that, they don't want you to mess with it, but it's a standalone unit. It only has 3 wires connected to it, and it looks like it's just positive, negative, and a sense. And if I look look inside of this, which we'll take a closer look at, it looks like it's just based on an oscillator and some voltage multipliers to get to 2000 volts. 2 kilovolts is what it's supposed to be set at. So it should be easy for us to see why it is not doing anything, because we can measure it completely by itself. So I have the high voltage power supply connected to 12 volts, which is what it needs, and it's only drawing 2.3 milliamps. And unfortunately, its output is still producing nothing at all. You can see it's sitting at 0 volts, and yeah, that explains it. There is no high voltage coming out of it. So we should take it apart a bit more and see what it looks like on the inside. And here's the module. Now looking at it from the top, it's really obvious that it's going to be using some kind of a voltage multiplier. The transformer is quite small. That's the one that's sitting over here, so it's not really meant to produce a lot of power. We do have some precision resistors on this side and on this side, which are part of the resistive divider. This is the business output of it. And then we do have a potentiometer in here, and I'll show you how that actually contributes to adjusting the voltage. Now if we flip it on the other side, we will very quickly see a bunch of familiar things. We see our voltage multiplier sequence of diodes in here. It's probably times 8. And then we have two ICs here. One is an op-amp. The other one is a precision 5-volt reference. So the precision 5-volt reference in combination with the op-amp can actually control the output, because we have a feedback circuitry with the voltage divider coming back from the output side. We do have a whole bunch of transistors in here, and then we should be building an oscillator. So an oscillator pulls and pushes current in the primary side of the transformer, which is exactly on this side right there. And that's going to produce a very large voltage, which is going to go through the AC-DC conversion of this voltage multiplier, getting a nice DC output voltage on the other side. And the feedback is closed with the op-amp as well. Now, it's something like this. When it's drawing only 2.3 milliamp, an immediate place to take a look is see if the oscillator is actually working or not. Because if the oscillator is not working, you'll get very little current. There's no activity, and that's exactly what was going on with this one. So I looked at the op-amp. The op-amp did indeed look fine. This transistor over here is an PNP transistor on the primary side of the transformer, which is what is responsible for pushing and pulling current out of it. I quickly tested that, and well, you know, it was dead. I actually replaced it. There it is. If I can bring it into the camera. There's a transistor I replaced, pretty straightforward. That basically used to sit right here. So it was a quick thing to try. This transistor indeed was a short circuit between two of its ports, so it definitely wasn't going to work. So let's see if this change actually has made any difference. And before I forget, this potentiometer is sitting on the 5-volt reference generator's adjust port. So by adjusting that, you're adjusting this voltage, which is part of the feedback, controls the whole thing. Now, coincidentally, I'm making a video all about high voltage power generation and signal generation, and that's probably going to come out before this video. It's kind of coincident that I'm working on this while I'm making that other video. Okay, let's give it a try one more time. And what do we have? Look at that, it started up, and now it's burning 24 milliamp. So it's significantly more, about 10 times more. And it is connected up exactly like before, and check it out, 1.9 kilovolt. That's what we're getting at the output, which is what we were expecting to see. So it is in fact working, and I knew it was working because I zapped my finger before that, as I wasn't very careful. But this is not a very dangerous power supply, because 24 milliamp at 12 volts is the total amount of power this thing is burning. So it's not a lot to begin with. That means that's the maximum amount of power you could ever have at a high voltage. But it certainly hurt my finger. Well, the unit continues to have problem after problem. I actually had to take the whole thing apart and put it all the way back together again, because I detected 3 other issues with it. The first thing was that as the stage would move up and down, which was working fine, it would crash at the very top and at the very bottom. And it's not supposed to do that. It's obviously supposed to detect that it has reached a limit, because it's got these optical detectors in there, and this piece of metal enters in the middle, blocks the beam, and it knows that it has reached, for example, the top. There's also an equivalent one just underneath it at the bottom that you can't see because the stage is at the bottom right now, and it's supposed to detect the bottom limit, but neither of those were working. So at first I thought that the control circuitry responsible for that detection, which is right over here underneath this, was the problem. You can see these big resistors are part of the stepper motor driver, and these 2 sets of wires come from those optical transmitters and detectors as well. And actually, at first I thought, well, the circuit must be broken, and I had to reverse engineer the whole thing to figure out how it works. It actually turns out that the photodetectors for both of them were dead. And that wasn't the first place I would have looked. It looks like that those photodetectors over time fail when they have a reverse bias voltage on them, and the transmitters are not on, and I think they just have failed over time. So I opened them and removed them and replaced the detectors. You can see the wire looks a little bit different. I couldn't find an exact replacement, so that was some work for sure to be done. Then the second issue I found out was that all those LEDs at the bottom that are supposed to illuminate the sample, a whole bunch of them were dead, and they were all white LEDs. So I had to replace all of those, which was quite annoying also, because they were all the way into really cramped spaces. And the third problem was that the camera was completely out of focus, so I had to finally adjust that. The issue is you can't test any of these until this whole thing is put back together. So it's just a really messy engineering, the way it is designed and kind of hacked together. But at least I think most of those problems are now gone. So I hope that you enjoyed this first part of the repair and putting the unit together. The computer is all the way back there. Everything works and I can actually do some scanning. That white box in the middle is an unrestricted tunable laser. It's unrelated to this. But in the next video, we're going to do a whole bunch of analysis as well as, of course, talking about the theory of operation of the unit. See you next time.